Hey everybody, hope you're doing okay. I promised you that I would show you the geometry of the Earth using the system that is related to what I've been showing you so far. I'm not the only one who's ever done this. If you take a look at the work from Robert Boyle in the 1600s, who produced the book called Curious Mathematical Forms, you'll see a lot of the same type of geometry that I've been showing you lately. But the thing is that instead of just calculations, it's helpful to be able to visualize the math. I'm an extremely visual person, and so just running calculations on a calculator is not good enough for me. I need to be able to see the geometry. And that's where all of this stuff comes into play, because what they tell us is that the Earth's diameter is 7,917.5 miles. They tell us the moon's diameter is 2,159 miles. The sun is 864,575. The problem with all of this is they're not showing the harmony of number, which I keep telling you guys about. And so today I want to show you the harmony in number, show you how it relates to the geometry of Earth, and then in another video I'm going to show you something really interesting about the distances that we see between the internal geometry that exists inside of the Earth, for example the size of the moon, these types of things, and then the size of the sun, and then the distance that these things are from each other. There's something very interesting about it all. And it definitely relates to some of these things I've been showing you as far as the pi increments. So this right here represents the diameter of the Earth. Now the diameter of the Earth, if we use the geometrical system here that keeps the numbers in harmony, is 7,920 miles, not 7,917 point blah blah blah. This is what keeps things in harmony. So in order to understand the way that pi is going to look, see, if we take these rings and we divide 7,920 by 22, you'll notice that down here we have 22 objects. And our center object right here is our pi increment. And believe it or not, our pi increment is 360. So if we divide this whole thing by 22, then it represents pi. If we divide the whole thing by 44, then it represents 2 pi. But I'm going to show you both geometrically and just kind of show you how it is fractal in a way. So if we take a look at our spreadsheet here, these are the numbers, and if we use pi increments, which is 180, then this is what it looks like. And when we get to 22, we actually get the radius of the Earth. If we use the 2 pi increments, then right here at 22 we get 7920. So 2 pi, the pi increments is what actually we want, because we want to show 7920 as 2 pi, which means 22 would represent pi, 11 would represent pi over 2, and so on and so on. So the way that this actually looks is, if we take a look at this drawing right here, and I've got these geometrical images over here in line to kind of show you what things look like. So if we take these 22 rings, and if we want to get the pi increments of 180, then what we have to do is we have to take this right here and we have to scrunch them one time, which means that we need to take all of these guys and scrunch them by 50%. And what this will do is place rings halfway through. It'll place rings in between these other rings, which are important because it's what gives us the increments that are 44. It gives us our 180 pi increments. And that's what it looks like And you can notice that some of these are lighter than the others. That's because what it's really done is put them in every other ring. The other ones are just duplicates. So this is a duplicate, that's a duplicate, and so on and so on. So if we come back over here, that's what's happening right here. So how do we understand what our 7 is? Well, our 7 basically is the 7920, and if we take that 44, since we're dealing with 2 pi, and we divide by 180, right? And then we multiply by 7, then 1260, the size of this right here, that's our 7. Now, since we know what these numbers are, let's go take a look at the factors real quick of these various numbers. 1260, 1980, 2520, 3780, 3960. Let's see what these things look like when we take a look at their actual factors and see if they match up. So if we take a look at our number 7, when we take a look at 7920 as 2 pi, we can see that this particular number, 1260, has 7 as an ending factor, which means that this is definitely the 7 of the system. If we take a look at 2520, it's a 7 also. And if we flip back over here and look at this right here, the 2520 represents the 7 if we were using 2 pi increments. The 1260 represents 7 if we're using pi increments of 180. So then if we take a look at the 1980 represents our pi over 2, right? Because this is 11. This is pi, 22. This is pi over 2, which is 11. So 1980. So if we take a look at 1980, we can see that it is an 11. You notice that it doesn't have a 7 as a divisor, it has 11 as a divisor. And then of course twice that, which would be our 2 pi increments of 360, we have 3960, and that is the radius of the Earth, and that has a divisor of 11. And you'll notice that it has 11 360s, or it has 22 180s. And this is exactly what we see when we take a look at this right here. So this is our 11, this is our 14. So let's just take a look at a couple more here. We have 3780, 7560. So if you notice, this is 21, so this is 3 times 7. So here's 7560 right here, and notice it has a factor of 7. And then 7920 has a factor of 11, and that's our 2 pi. So you can see that all of these have the divisors that they should when we take a look at the actual number itself. So when we flip back over here and look at this thing, we can look at this 1260 right here and know that that's definitely a 7. We can look at the factors and tell that that's a 7. So what's interesting about this system here is if you take the double triangle, or the Star of David, or the six-sided star, and you place it inside of here, and you place your rings inside of here, then you'll notice that where these yellow squares are, that represents pi, and the ring that you see here represents the circle that it's squaring. So if we come over here and take a look, so 1260, that represents our smallest blue circle right here, and what's underneath that isn't actually there, but we see that, let's see, 1980, which is this right here, and 3780, or actually 2520. So if we take 2520, take 1980, and divide by 2520, we get pi over 4, which is exactly what we should get, because this is an 11, and the number 14 is 2520 right here. and that represents this blue circle. And so these rings that you see here, the 22 rings and then the condensed rings, form natural circles that, with this six-sided star placed in here, form natural squares that perfectly square the circles as you go up. So when you take these stars and decrease them by 50% each time, you're going from 2 pi to pi to pi over 2, and so on and so on. So this red circle that you see right here represents the moon, and that moon falls in on this ring right here that you see with inside of the Earth. So if we take the moon, which is 2160 actually, and we take 2160 and we divide that by the actual diameter of the Earth, we get 0.2727, which is actually the exact ratio of the moon to the Earth. These yellow corners that you see here and these rays that you see moving up represent a 51.84 degrees like we see in the Great Pyramid, and its reciprocal, which is 38.16. The three circles that you see here, which represent the 1260, well, that represents 3 plus 142,857. So that represents pi. And this circle that you see right here represents the pi increment of 180. So we actually have 1260 times 3 plus 180, and that represents the 3.142857. If we take a look at this over here, we have 6 of these. We have 1, 2, 3, 4, 5, 6, and then we have a pi 2 increment that finishes it off, and that is the 6.285714, which represents 2 pi. So as you can see here, that the system is actually very simple in the way that it's designed, and geometrically it's very clear, and you can see what's actually going on. What's interesting about these rings, and I've shown you some of this before, but I'm going to go into it in another video, is that these rings, which form the internal part, for example, the moon that you see right here is actually a ring that falls into the division of the Earth. When we take a look at pi, is actually the size of the moon. And there's an interesting thing regarding the distance of the Earth to the moon, and a certain number that I've shown you before. And there's a consistency with all of the divisors inside of the Earth associated with that. And I'll show that to you in the next video. But this is what it looks like right here. So you have 3 plus your 142857. You have 22 rings, and then condensing them, you have these extra ones down here, so that these extra rings that you get here allow you to see where the circle is being squared, and so forth, so that you can actually see where your pi is and your other ones. This is what it looks like geometrically right here if you're going up the ladder. So we can see that this is 180, 2 of those makes 360. So you can see that I have my 360s right here and my 180s in between. These yellows represent where pi is. The blue represents where the 7s are. And I forgot to put the 2520 right here, which I'm going to do before I upload that image. But and as you can see, every 7, so we have 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And then on these, we have them every 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, all the way to 22. And then I don't think I placed one on 33. But interestingly enough, the 33 also happens to be the 5940 that you see here. If you take a look at one of the triangles here, the triangle that reaches from the top of the circle to the sides of the circle, if you're not looking at the six-sided star but only looking at a triangle, that would actually represent the 33. That actually represents the 5940, because it is the 7920. The way you get that is, if you want to if you want to put a triangle and inscribe it inside of a circle, I would take 7920 and I would divide that by 1.3. and 5940 is the size of the triangle in its height. The other way to do it would be to take a look at the ratio of 0.866025 to 1, but I like doing the 1.333 a little bit more. So anyways, that's what the geometry looks like as far as the Earth goes. I want to show you some really interesting things that I've shown you before regarding these rays that come out of the, for example, if we take a look at the angular diameter of the moon, and then this internal geometry right here, there's something interesting about it that I'll show you in the next video. So I hope you guys enjoyed that, and I'll talk to you soon.